we're going to be doing today is looking at 10.3. We're going to be graphing quadratics and then looking at completing the square stuff. So let's go ahead and jump right in. So yesterday we looked at this. This form is called, remember, Vertex Form. It's y equals a parentheses x minus h squared plus k. So let's talk about a quick few of these. Remember, anything in the parentheses, it's going to move it left or right. And anything here, it's going to move it up or down. Okay? And it's always the opposite. So if it says a negative, and I should only the opposite inside the parentheses. So right here, let's go ahead and look at these step by step. Okay? So the first thing is I got my a value. My a value is negative 1/2. So what does that actually do to my graph? Well, first thing, it's going to make it open down. And it's going to make my graph a little wider. So the smaller the number, the wider my parabola will be. Now my h value is negative 2. Now, really quickly, remember it makes us go left and right, and people always think, oh, it's a negative, so I should go to the left too. In fact, though, it's the opposite of that. It's to the right too. So my transformation, I'm going to move to the right too. And then finally, my k value here, my k value is just positive 4. And what that's telling me to do is just to go up 4 units. Now, why did they call this a vertex form? Well, it's quite simple, as they show us the vertex right here. My vertex is 2, 4. Remember, it's always the opposite of this number. So it'd be 2, 4. And the axis of symmetry is where does this graph cut in half, okay? So remember, these are always y equations, so that would just be the y value here, so it'd be y equals 4. And since this graph is going down, I would have a maximum value. It tells my highest point, which would be the vertex, which is just 2, 4. Okay? So let's go ahead and actually graph this. So the first thing I'm going to do is I'm going to go to 2, 4, over 2, up 1, 2, 3, 4, put a point right here. So then what we're going to do is we're going to plug in some values. So I think the easiest value to always plug in is 0, 0. So if I plug in 0, 0 here, excuse me, I should say, it's not 0, 0, excuse me. If I plug in an x value for 0, what would my y value be? So if this was 0, I would have 0 minus 2, which is negative 2, to the second power. So negative 2 to the second power is positive 4. So positive 4 times the negative half, that is negative 2, plus 4 is positive 2. So that would be here. So I'm 2 spots away from the origin, from the axis of symmetry, so I go 2 spots over here. There you go. I'm trying to think. Okay, so that's good enough to graph there. So if I went ahead and graph my parabola, here you can see all the features. It's going down, has a vertex of 2, 4. I actually have an axis of symmetry right here. Cuts my graph in half. And I went to the right 2 and up 4. So that was just an introduction. So guys, if you're in my class, you know how I feel like the pictures they put on the curriculum is always so silly. Finally, they put something awesome from Mario. If Nintendo ever saw this, they would not allow that to be posted in their curriculum. But that's okay. So, really quickly, whenever it's written in vertex form, it's called completing the square. So I'm going to show you just a quick little thing here. It always wants us to talk about these quilt shapes that it wants us to use. We're not going to use these little quilt patterns, these quilt values. Now, if I had something that looked like this, I'm just going to show you one example. So if I had this formula, x squared plus 4x plus 4. Now, there's numerous examples of these, but this is the first one. We would say this equation is a perfect square. And the reason why is if you take these algebra tiles, this would be x squared. This would be my x value, so I'm going to place 2 right here. So this would be 1x, 2x. And then the same thing, I'm going to put it over here. I'm going to do it as perfectly as I can. So that would be 4x, that represents there. Now, how many of these little tiles would I need to finish the square? Well, that would be 1, 2, 3, and lo and behold, it would be 4 squares. So if you look at this, guys, this is values x, this values x, this values x, this values x, and this is 1, 1, 1, 1. So right here, I got my x squared, I got my 4x, and I got my plus 4. So what we're going to be trying to do is what's called completing the square. Now, how do we do that? Well, I want to show you that shortly. But when we hear this idea of completing the square, we're trying to come up with a perfect formula that I can draw this. Now, anytime it says a quilt model, though, we're going to be skipping that. You guys don't have the algebra tile, so on and so forth, okay? But whenever you say completing the square, it's going to be basically turning something that looks like this in standard form into something that looks like vertex form. So when you see vertex form, that is somewhat kind of like completing the square. We get there by completing the square, okay? So it says Optima's niece Jenny works at a shop taking orders of drawing quilt diagrams. When the shop isn't busy, Jenny pulls out her math homework and works on it. One day she's working on a graphing parabola and notices the equation that she's working with is a lot like the order from the quilt blocks. For instance, Jenny is supposed to graph the equation y equals x minus 2 to the second power plus 4. She thinks it's funny. This would be in order where the length of the standard equation is reduced by 3. Then we would add a little piece of fabric to get the area of 4. We don't usually get orders like that, but it still makes sense. I better get back to thinking about parabolas. So fully describe the parabola that Jenny has been assigned. So let's go ahead now and jump to number 1 over here. So, because we're not going to be doing quilt, so any of the quilt stuff I'm going to be just skipping ahead. Jenny returns to her homework, which is about graphing quadratic functions. Much of her dismay, she finds that she's given x squared minus 6x plus 9. Oh dear, thinks Jenny, I can't tell whether the vertex or any of the transformations of the parabola in this form. Now, what am I supposed to do? Wait a minute, is there an area of a perfect square? Use your work from part 1 to answer this in Jenny's question. So really quickly, I'm going to show you guys how to do these. And let's start with, you're going to start to see a shortcut. So what you need to do is answer Jenny's question just fine. I can't tell what the vertex, okay. So basically you're given this equation in standard form. X squared minus 6x plus 9. And what you're going to be doing is you're saying like, okay, how can I write this in in vertex form? So y equals parentheses x minus h squared plus k. This is vertex form. Here you can't tell the vertex, you can't tell a lot. So what you can think about is there a way to convert this into this form? Okay, and there is. It's called completing the square. So we're going to look more into this in, I believe, 10.5 or 10.6. But essentially what we're trying to do here is think about, hey, are there numbers that multiply to a times c and add to b? So are there numbers that multiply to 9, because 1 times 9 is 9, and add to negative 6? And you're like, yeah, negative 3 times negative 3. And we're going to go over all this. I'm just going to show you a quick way on how to convert this. And you'd say, oh, okay, my factors here, if I have an a value of 1, would just be x minus 3, that is this value right here, and times x minus 3. And if you look at this, x minus 3 times x minus 3 is just x minus 3 squared. So we're going to have a whole lesson on this on 10.5 on how to do this. But I just want to introduce you to that, okay? So this is x minus 3 to the second power, because when you're multiplying two things that are exactly the same, you can put that to the second power. So essentially, guys, this right here is equivalent to y equals x minus 3 squared. And this is called like a perfect square right here, okay? So right here, I have like a plus 0. So my vertex there, yes, you can tell what your vertex is. It's positive 3, 0. All right, so let's go ahead now and look at this. It says, Jenny says, I think I figured out how to change the form from my quadratic so that I can get the parabola. I'll check to see if I can make the equation a perfect square. Jenny's equation is y equals x squared minus 6x plus 9. All right, so we kind of just went over this, but just as a quick review, you are trying to figure out If I multiple two binomials to each other, could I get this value? All right, well, I know these are x's, and these are going to be two regular old numbers, so it would end up looking like this. And like I said, I'll go over it really quickly again, but in 10.5, we're going to have a whole lesson on this. You're essentially trying to find out two values that will multiply to a times c and then add to our b value. So 1 times 9 is 9, and my b value is negative 6. So I'm looking for numbers that multiply to 9 and add to negative 6. So I know they're both negative, and I know that 3 and 3 will add to negative 6 and multiply to 9. Therefore, if you have a coefficient of 1, these would be your values over here, and then your x's would just be in the front. We're going to look at more complicated versions before. And one more time, I know that this is y equals x minus 3 to the second power. I just completed the square there, okay? So it says the new form of the equation would be y equals parentheses x minus 3 to the second power. Now the vertex of the parabola is basically always h, k, and my k value is 0, so my values here would be positive 3, comma, 0. Okay, now it says graph with at least 3 accurate points on each side. So first off, I need to start with my vertex. So if you're ever making these little charts when we're graphing, what I always do is I plug in my vertex, which is 3, 0, and I'm going to just choose some values. So I got a 2, a 1, and then like a 4 and a 5. Now, whatever the equal distance away from the vertex is, they're going to be the same values. So I'm going to have the same values here because they're both one above and one below the vertex, and these will also be the same value. So let's go ahead and start by plotting 3, 0 right there. So I got my vertex. And now I'm just going to go ahead and plug in some values. So let's go ahead now and plug in 2. So if I plugged in 2 or 4, you'd get the same answer. You'd get 2 to the second power minus 6 times 2 plus 9. So this would give me 4 minus 12 plus 9, negative 8 plus 9, which is negative 1. So this is negative 1, negative 1. Or excuse me, positive 1, positive 1. Remember, you know those are the same, because if you plug in 2, you'll get the same answer as plugging in 4 because they're both equal distance from the vertex. So now let's go ahead and plug in 1. So it'll be 1 to the second power minus 6 times 1 plus 9. So it'll be 1 minus 6 plus 9. Negative 5 plus 9 is negative 4. So I know that this is, positive 4. This is positive 4, and if I plugged in 5, I would also have positive 4. So let's go ahead now and over here. I got a positive 4, and then over here, also a positive 4. So you got the shape of your parabola. There we go. All right, guys, so let's go ahead and really get into the meat of this lesson. So I thought the first part was a little tricky because you're teaching you how to like factor things out and come up with it in that form. We haven't had the formal lesson on that yet, but let's go ahead and look at this as completing the square. Basically, what we are trying to do is we are going to try to find how can I create a perfect square? So what value does this need to be in order to then rewrite it in vertex form? So what number does this need to be? So what you need to do is first find the appropriate c value. Now your c value is always your b value divided by 2 taken to the second power. Okay, so let's go ahead and look at this and find this missing c value. So you're going to take 24 and you're going to divide that by 2, which is obviously 12. So that is going to give me 12 to the second power, which is 144. So I'm going to put plus 144 here. Now, I'm going to show you the shortcut. So just so we know, one more time, we're looking for numbers that multiply to a times c, which would be 144, and add to 24. In this instance, since we're looking at all perfect squares, I'm going to take these values and I'm going to just show you how to do this. To turn it into a perfect square, it's a little shortcut. You're going to do y equals a parentheses x and then whatever b divided by 2 is. So b divided by 2 plus or minus b over 2 squared And we're going to look at plus k shortly, okay? So right here, if I were to do this, then my values would just be y equals, my a value is just 1, and then I'm going to have parentheses x, and then 24 divided by 2 is 12, so plus 12 parentheses squared. So that's it for this part. We're not looking at the k value right now. We're just saying, what would I have to write, what would need to be my c value in order then to write it in vertex form. So let's go ahead and try this one out now. We're going to look at the b value. So the first thing is I need to know is whenever you are completing the square, you're always going to be adding a value. If your b value is positive or negative, you're always going to be adding the c value. So to get the c value, remember, c is equal to b over 2 to the second power. So c equals negative 8 divided by 2 to the second power. So c equals negative 4 to the second power, which is 16. So think about this. What is going to multiply to 16 and add to negative 4? Well, to do that, all we're going to do is to write this, and I'm telling you right now, this is a perfect square. So to write this, that is a perfect square, into vertex form, all you're going to do is go ahead and take your x value, and then you're going to plus or minus, so this is a minus, your b value divided by 2, and you're going to take this entire thing to the second power. Now you can always check your work, and this is just equal to x minus 4 times x minus 4. And if you were to FOIL this, we'll look at several different ways on how to solve this. This would give me x squared minus 8x plus 16. It's the same exact answer. So what the question once again is, what does this c value need to be in order to make this a perfect square? All that is your b value divided by 2 squared. So let's go and look at this. Remember, once again, I'm just trying to figure out this c value. So to do that, all we're going to do is take negative 10 divided by 2, and we're going to square it. So we're going to have negative 5 squared, which would give me 25. So I'm going to be adding 25 here. Okay, so then the next part is to write this in vertex form. This would just be x minus 5 parentheses to the second power. Remember, it's always your b value divided by 2, which is going to be that part. Now this one, d, is a tad different. What is different here? I have this coefficient of 2. When this happens, it's a little tricky. Whenever you have a coefficient that is not 1, you're going to have to factor some stuff out first. So I look at this 2 and I say, oh, I can factor out a 2. And now I'm left with x squared plus 6x plus whatever value I need to do to make this a perfect square. So you're basically going to ignore this 2 out in front that we just factored out. So now you're going to take, to find your c value, you're going to take that 6 divided by 2, and you're going to take it to the second power. This will give me 3 to the second power, which is 9. So I will add this 9. So now what we are going to do is we are going to make this into a perfect square. We're going to transform this to vertex form. So to do that, what we need to do is what two numbers multiply to 9 and add to 6? Well, that would be 3. So this would be this 2 in front. Then you're going to have x plus 3 squared. And then you're done. Okay, but let's go ahead now and look at this next part. I am going to give you this equation. Y equals x squared plus 4x plus 2. And remember, I want to convert this into vertex form. So this is standard form. I want to convert this into vertex form. That is y equals a parentheses x minus h squared plus k. Now, how do I convert this? How do I convert this into here? Well, all we would need to do is confirm that this is a perfect square. So this c value, remember, needs to be your b value divided by 2 squared. Let's see if that's true. So if I took this 4 divided by 2 squared, that would give me 2 to the second power, which equals 4. Uh-oh, guys. This 2 does not equal that 4. So it says, does this expression fit the pattern for a perfect square? And we would say no, because the c value does not equal b over 2 squared. So we need to fix this. Now, any one of these quadratics that we're looking at today, we can manipulate them so they are a perfect square and convert it into vertex form. So let's go ahead and look at this. It says use an area model to figure out how to complete the square. It could be written like this. So we're not going to do any of the area models. We're going to go right to the algebra part. So so let's see, identify the vertex of the parabola. Okay, so let's go ahead and look at this. The equation I was given was y equals x squared plus 4x plus 2. So we're going to write some steps here. So first step, let's make sure that the coefficient of x squared is 1. All right, check. Second thing, we are going to group x squareds, my a and my b values, I should say. Ax squared plus bx together. Okay, so what would that look like? That would look something like this. What I'm going to do is I'm going to rewrite this as y equals parentheses x squared plus 4x, and I'm going to leave this blank spot for a new c value here. And then this plus 2, I'm going to write it in a little darker blue. I'm just going to have plus 2 here. So I want you to realize I grouped the x squared and the 4x together, and I left another space. Let's see, and then we're going to leave space for a new c value. All right, so now what we're going to do here is we are going to complete the square. So it's basically saying let's say find c value to complete the square. So if you guys remember previous lesson, we were just saying, hey, what can the c value be to get this to complete the square? So if I just gave you the problem x squared plus 4x plus blank, what would that c value need to be? Remember, c is equal to 4 over 2 to the second power. So 2 to the second power is just 4. So I would add a 4 right here. But now my equation is completely different because I just added a 4. You can't just add a 4 in here and expect everything to be okay. So to keep the equation equivalent to what it was before, if I added a 4 right here, you need to subtract a 4 on over here. So then your final step, let's just simplify. Now watch this. We know how to convert this into a perfect square form. So this would be y equals x plus 2 parentheses squared. And then 2 minus 4 would be negative 4. Oops, would be negative 2. And this is vertex form. Your vertex here is negative 2 comma negative 2. So we're going to do a bunch of these, okay? So we're going to look at these shortly. So it says, is the equation you have written equivalent to the original? Now the original one was y equals x squared plus 4x plus 2. And in vertex form, it was y equals x plus 2 parentheses squared. What was that, minus 2? Minus 2. All right, so are these equivalent? Well, all I would have to do is simplify this to find out. So y equals x plus 2, minus 2. Right here, x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 plus 2 is 4. Minus 2. When I combine like terms, I'm going to get x squared plus 4x plus 2. And lo and behold, woo, these are exactly the same. Boom. All right, so now let's go ahead and look at a few of these together. We can go ahead and graph the vertex form relatively easy. So first off, I had a vertex of negative 2 comma negative 2. And remember, it's always easy to choose points that are relatively the same. equal distance away from the vertex, I should say. So 1 above, 1 below, 2 above, 2 below. So let's go ahead, -2, -2. And then if I plugged in 0 to these equations, you can plug it into either one, it doesn't matter. If we plugged it into x squared plus 4x plus 2, if I plugged in 0, I would get an answer of 2. So that means I know if I plugged in -5, I would get an answer of 2. If I plugged in an answer of -1, I would get something that looks like -1 is my answer. So I know that -3 would also have that answer as well. And I can go ahead and graph this. So identify the vertex of the parabola with 3 accurate points on each side of the line of symmetry. Cool. All right, use the area model on the following function to figure out and complete the square so that the equation can be written in vertex form. So what we are going to do, guys, we're not going to do the area model. What we're going to do is rewrite these in vertex form. Now, we have not looked at a lot with the plus k. What we focused on mostly up until this point has been this part in previous lessons. So now we're really going to be focusing on this k. So those steps that we wrote down, we're going to do the same exact thing. Right now, I know that this is not a perfect square because if you were to divide 10 by 2 and take that to the second power, that would give me 5 to the second power, which is 25. Well, this 8 does not equal 25, so I know this is not a perfect square. So what we need to do is figure out how can I rewrite this so it is a perfect square. So previously it says make sure you have a coefficient of 1, which I do. And then I'm going to group the ax and ax squared plus bx. And I'm going to make a new value for my c. So I'm going to have x squared plus 10x plus this number that I'm going to make so it makes a perfect square. I'm going to take this plus 8. I'm just going to kind of leave it out here on the side. It's not included in my perfect square. We already figured it out. It doesn't work. It's not a good fit. Okay? So now what needs to be this c value in order for this to be a perfect square? Well, that is when I do my 10 over 2, which get me 5. And we're going to take that to the second power, which would give me c equals 25. So I know that c is 25. I'm going to put this right here. Uh-oh, my equation is completely unbalanced. Good news, I can make this into a perfect square, but it's not balanced. You just added 25 there. You can't just do that. So if I add 25, remember I'm still on the right side of the equal sign, I need a minus 25 over here. So then right now, I have all the components to make a perfect square. So in the light blue, what I can turn that into is x squared plus 10x plus 25 will convert down into x plus 5 parentheses squared. And then 8 minus 25 is negative 17. And then you're done. Okay, so a few parts. Just remember, we're going to have a formal lesson on how to convert these, but how did I do that? What two numbers multiply a times c? What two numbers multiply to 25 and add to your b value? Add to 10. Well, 5 and 5. Since you have a coefficient of 1, that would just be x plus 5, x plus 5. Since you're multiplying those, that would be x plus 5 squared. All right, and this minus thing is our k value, which we're going to manipulate. So really quickly, if it asks for our vertex, let's see if it did ask for our vertex. Be written in the vertex form. It doesn't ask, but just so you know, it would be -5, -17. Boom. Let's go ahead and look at the next one. So we're going to go a little quicker on these ones. First step, make sure the a value has a coefficient of 1. It does. So we're going to group the ax squared and the bx, and then we're going to add a new spot for our c value to make a perfect squared. And I'm going to have this -6 just hanging out here because it is not part of the perfect squared. So what we're going to do is to find our new c value that would make a perfect squared. I'll take a, divide it by 2, and square it. This would give me 4 to the second power, which is 16. Boom, so I'm just going to add 16 here. Uh-oh, my equation's not balanced now. So since I added 16 right here, I need to subtract 16 right here. So then this will give me y equals x plus 4, parentheses squared, And then negative 6 minus 16 would give me negative 24. Okay? Just as a reminder, guys, how did I get this? Just as simplest terms, y equals x plus b divided by 2 squared. Okay? So my b value is here. That'll work on most of these anytime you have a coefficient of 1. And we'll learn how to factor those as well, okay? So let's go ahead now and look at my next one. Here, let's go ahead and rewrite this. Y equals parentheses x squared minus 12x plus my new c value to make a perfect square. And then I'm going to have my plus 7 out here, which I'm going to mess around with because you can't just be adding stuff. To find my new c value, what you're going to do is take your b value, divide it by 2, and you're going to square it. Okay? So this will be negative 6 to the second power, which is positive 36. So I'm going to add 36 here, and then I'm going to subtract 36 here. So let's go ahead then and look at this. If I were to make my perfect square now, this would then just be x and then minus 6 parentheses squared minus 29 is what y equals. So one more time, that's in vertex form. You know your vertex is 6 comma negative 29. And finally, let's go ahead now and look at this one. I have y equals parentheses x squared minus 6x plus my new c value, and then I have my minus 5 here. So what I need to do is figure out what my new c value is so I could make what's in parentheses a perfect square. And we do that by taking your b value, dividing it by 2, and taking it to the second power. So negative 3 to the second power is positive 9. So I'm going to add 9 here. Now since I added 9 here, we need to subtract 9 here. So this would give me x minus 3 to the second power. So I just factored all this into here, minus 14. And this is now vertex form. Now really quickly, guys, I want to stress that standard form, I want to stress that standard form right here is equivalent to vertex form. I haven't stressed that enough. Those are exactly the same equations. One's just written in standard form, one's written in vertex form. Think about like y equals mx plus b in a linear equation and slope-intercept form. Same equations, okay? They just describe different things. So this one will help us describe the vertex. And that's why we complete the square. All right, so Jenny hoped that she wasn't going to need to figure out completing the square of an equation where the b value is an odd number. Of course, that was the next set of problems. Help Jenny find the vertex of each problem. All right, so when I look at this, guys, let's go ahead now and look at this. Every time we've done this so far, we've had a b value that was even. Now, it's nice because we divided by 2. But you can still solve it if it's odd. So if I'm going to have this problem of g of x is equal to parentheses x squared plus 7x plus this mystery c number to make a perfect squared plus 10. So to get my new c value, I'm going to take 7 divided by 2 and square it. This is going to give me a 49 over 4. So since I added 49 over 4, my equation is imbalanced, so I need a minus 49 over 4. So then I'm going to have this new equation then, x plus 7 over 2, parentheses squared. And then I have these values. Well, let's convert these to fractions. This is 40 over 4 minus 49 over 4, which gives me negative 9 over 4. That's what g of x equals. Okay? All right, so let's go ahead now and look at this one. What if it's a 5? Well, no problem. We can still solve it the same way. So first off, I'm going to have g of x equals parentheses x squared plus 5x plus some mystery blank number plus 2. So then to get my c value, I'm going to take this 5 and divide it by 2. Now I'm going to take it to the second power, which will give me 25 over 4. Since I added 25 to the 4, I'm going to subtract 25. I'm going to subtract 25 over 4. So this would give me then g of x is equal, I'm going to complete the square here, and rewrite this as x plus 5 over 2 squared. And then now I'm going to subtract these. So 2 over 1 is equivalent to 8 over 4. And when I subtract these, then I'm going to have negative 17 over 4. And that's your final answer. And your vertex right here is just negative 5 over 2, comma, negative 17 over 4. As a quick reminder, this vertex form is equivalent to standard form up here. Okay, so now on number 8, we're going to skip this. And now we're going to go ahead and look at these trickier ones. We're going to jump to number 9. So we're not going to do any of the quilt numbers. Now number 9 is tricky because if you notice, what is different here? Let's look at my a value. I have a 2 here. So what we need to do is we need to turn this into a perfect square. Now there's one tricky wrinkle to it. We've got to factor, well, first off, let's group our values. So I'm going to have f of x is equal to, same idea, I'm going to group 2x squared plus 16x plus my random c value, and then I'm going to add 21. So there's no difference there. Now what I'm going to do is I'm going to factor out this 2 here. And there's this invisible number that I'm going to factor out a 2 out of. We just don't know what it is yet. So this will give me 2 parentheses x squared plus 8x plus the mystery c number. 21 did not have anything factored out of it, so I'm just going to leave it there. Now the steps are going to be very similar. The only difference is this, what I'm going to add out here is going to be a tad different. So let's go ahead and look at this. I'm going to take my, to get my new c value, I'm going to take my 8, divide it by 2, and then square it. So c will give me then 4 to the second power, which is 16. Now, I am going to put a 16 here. Now the problem is, students think, oh look, I'm all done. There's a 16 here, so I'm just going to go ahead and minus a 16 here. That's not the case, because it's 2 times 16. If you were to redistribute this 2 into here, it's not adding just a 16, it's adding a 32. So the 16 is 16 times 2, which is 32. So you essentially added 32 into this equation, not 16, but 32. So you're going to have to subtract 32 from this equation. So this is how you would get an a value in your a parentheses x minus h part. So it would be that 2 right there. So if I were to focus on this, the 2 stays the same. I then find the perfect square of this part right here, which would then be x plus 4, and then the square would come on the outside of that. And then I would just do 21 minus 32, which is negative 11. Okay? So the only difference here is after you group it, you factor out a 2, you still figure out what your c value is, but whatever you add, whatever you subtract out here, you're going to have to multiply it by your a value, because remember, you're not just adding a regular 16, but you're adding 2 times that 16, which is 32. So you're going to minus 32 here. And really quickly, if you were to redistribute all of this, figured out what all this equaled, it would simplify back to here. So these two things are equal, okay? Now, last type of problems here is, what if I have this negative? Well, the negative in front of the a value. It's one little difference. It's kind of very similar to the previous one in number 9 we just did. So let's go ahead and look at that together. So same idea. We're going to have the f of x. I have this equals negative x squared minus 10x. And I'm grouping these together plus some mystery unknown number. And then I'm going to have this minus 29 here, okay? So now what we want to do is I'm going to factor out a negative of these two values. So I'm going to have then this negative x squared plus 10x plus the mystery c value. I'm still going to have this minus 29. So really quickly, the only difference is instead of the negative being right here and right here, you factored it out and it turned these two values positive, okay? Now this plus values is just kind of a placeholder. So you could add a positive number, you can add a negative number. It doesn't really affect when you factor out that negative, okay? It's just basically a placeholder for the time being. So now what I'm going to go ahead is I'm going to go ahead and take my 10. I'm going to find my c by taking that 10, divide by 2, and then squaring it, which would give me 5 to the second power, which is 25. So I'm going to add a 25 here. Now our go-to thing is then to put a subtraction 25 here, but remember, you're not adding a 25. If you distributed that negative, you would actually be subtracting a 25. Since you'd really subtracting a 25, you would add 25 on the outside. So if you ever pull anything out, whether factoring out a number like we did on number 10 or factoring out a negative, to figure out if I add or subtract to this k value, you're going to have to redistribute that negative or that coefficient, your a value, into your c value to actually see what you are adding or subtracting to the k value. So let's go ahead now and look at this. I would have a negative 1. That 1's invisible. You don't technically need to write the 1, but you must have the negative. X plus 5 squared. And then we would have a minus 4. So that's vertex form. And you can tell my graph opens down. I have a vertex of negative 5, negative 4, so on and so forth. Okay. Now, on your diagram, it says go ahead and look at, solve it with an algebraic model and a different type of model. We are only looking at the algebraic model, okay? So we have a handful of these, and these are the things that we're going to be factoring out, pulling out on the last few ones we do here. So really quickly, we are going to have y equals, remember, we are going to group ax squared plus bx values, and then we're going to add an invisible c value, and then we're going to have the plus 8. So step 1 is let's factor out everything we can. So we can factor out a 3. So I have 3 parentheses x squared plus 4x plus my mystery c value. So my mystery c value, remember, is just take 4 divided by 2, square it, which would be 2 squared, which is 4. So I have a 4 here. And remember, you need to figure out, am I just going to subtract 4? Remember, you added 4, so you need to do the same over here. But you need to double check, did I just add a 4? Well, no, because I have this coefficient of 3. So what number did I actually add in there? If I were to redistribute this 3 into everything, I didn't just add a 4, I added a 12, because 3 times 4 is 12. Since I added a positive 12, I'm going to have to subtract 12 to keep the equation balanced. So that means then I'm going to have this equation, y equals 3 times, and I can go ahead and rewrite this as x plus 2 squared minus 4. So you have a very narrow graph, parabola I should say. You have a vertex of negative 2, negative 4, so on and so forth. You can look at the transformation, all that good stuff. All right, so let's go ahead now and look at the next part. Letter B, same idea. We're going to go a little quicker on these now. Y equals, and you can even learn to factor it out in the beginning. So 2 parentheses x squared minus 6x plus the mystery number. Remember, I'm just kind of combining steps, so I would have grouped this before I factored it out. So I'm not really factoring out a 2 of that 23 there, okay? So then I'm going to take my c value to get negative 6 over 2 squared, which is negative 3 squared, which is positive 9. So I'm going to add a 9 here. Now remember, you don't just minus 9 because you realize it's not just 9, but it's 2 times 9, which is 18. So you're really adding an 18, so you minus 18. So then the next thing is you can complete the square by writing y equals 2. That's your coefficient of 2. Now we complete the square. Again, x minus 3 squared. And then my k value would just be right here, and 23 minus 18 is positive 5. Okay? Here we go. Remember, we are going to group these first. 2x squared plus 16x plus the mystery c value plus 21. Then what you're going to do is factor out that 2. So 2 parentheses x squared plus 8x plus a blank plus 21. And then what we're going to do is we're going to complete this square by doing 8 over 2 to the second power, which would give me then 4 to the second power, which is 16. Remember, you didn't just add 16, but you added 2 times 16, which is 32. So we are going to minus 32 here in order to keep my equation balanced. I can rewrite this as x plus 4 to the second power. So it'd be 2 parentheses x plus 4 to the second power minus 11. Do not forget that this in standard form is equivalent to this in vertex form. All right, so far all of Optima's orders have contained a positive leading coefficient. Optima knows that drawing a diagram will be impossible when the leading coefficient is negative. Use your knowledge to complete the square algebraically to write the following function in vertex form. So we went over this. We're going to go over it again. Let's go ahead and look at the last few examples. So first thing that we would do here is we pull out, no, first we would group it, negative x squared minus 10x plus the mystery value and the minus 29. We are going to factor out a negative 1, turn this into x squared plus 10x, and remember we don't know if this is plus or minus right now, so we're just going to write plus my c value. Since this is not grouped in there, I'm just going to have minus 29 here. Next, what we're going to do is we're going to find our c value by doing 10 over 2 to the second power, which is 25. So I just added 25 here. So remember, you don't write subtract 25 because you need to see, I need to redistribute this. This is not really a 25, but I actually just added a negative 25. Since it's a negative 25, since we introduced a negative 25, to make it still equal to the previous, we need to add 25 here. So now when I rewrite all this, I'll have y equals negative 1. I can rewrite that as a perfect squared as x plus 5 squared. And then negative 29 plus 25 is negative 4. All right, looking good. So we only got a few more. Last one here. So we got y equals parentheses negative x squared plus 6x plus my mystery c number to make the perfect squared plus this negative 2 that doesn't fit in here. So what we're going to do now is we're going to factor out a negative 1 to get x squared minus 6x plus the mystery number, and that minus 2 is not affected by factoring out that negative 1. So now what we are going to do is we are going to figure out my c value, which is negative 6 divided by 2 to the second power, which is negative 3 to the second power, which is 9. So now I'm going to rewrite this as y equals, the negative 1 is my a value. Then as a perfect square, this would be x minus 3 squared. And I kind of jumped the gun there really quickly. I want us to realize that I did not just add a positive 9. I added a negative 9. So since I added a negative 9, I need to keep this balanced by adding a positive 9. So then that would turn into plus 7. Alright guys, so we just figured out how to rewrite this from standard form into into vertex form by completing the square. This lesson can be very tricky, so if you have questions, please be ready to report them to me next time I see you. Alright guys, have a great day.